A 3 kilogram ball is accelerated from rest to a speed of 10 meters per second. And to be honest, this word right here is a key word. It means velocity, and in this case, velocity initial. So we have a mass, that is 3 kilograms. We have a velocity initial. The rest tells us that that is 0 meters per second. We have a velocity final, and that equals 10 meters per second. So if we solve for A, our unknown is what is the change, also known as delta, rho, or momentum. And the units that we can use are kilograms times meters per second. Now we can pick and choose parts of the impulse equation. So I'm going to choose the change in momentum equals mass times velocity final minus velocity initial. Now, if I replace numbers for letters, change in momentum is what I'm looking for, but I know that mass is 3, and I know that velocity final is 10, and velocity initial is 0. Now when I simplify, I get change in momentum equals 30, but I need to get the units correct, so I say kilograms times meters per second. Well, that's part A. For part B, if I recognize that impulse, which is the thing that I'm looking for right here, that word impulse, I can basically pick a part of the formula equals force times time. Does that help me? No. Equals mass times velocity final minus velocity initial. Not yet, but I can make it equal to change in momentum. If I know impulse equals change in momentum, and did I just figure this out? Impulse is 30 kilograms times meters per second. A 3 kilogram ball is accelerated from rest to a speed of 10 meters per second. This is exactly the same as my A and B, so I know that change in momentum equals 30 kilograms times meters per second. If a constant force of 40 newtons is applied to change the momentum of the situation, for how long does this force act? And so now we need to interpret what that word means. And so what are we looking for? We are looking for time. Seconds. So I'm going to choose parts of the impulse formula, force times time, because I have those characteristics or I'm looking for them. I'm going to make it equal to change in momentum. In this case, the force is 40 times t equals change in momentum is 30. In order to get t all by itself, I'm going to divide by 40, so I cancel. Whatever I do to the left, I have to do to the right. T equals 0.75 seconds.